We present the paper Structured Action Prediction for Teleoperation in Open Worlds. The user controls a robot arm using an Oculus VR controller and an on-screen interface. Here, the task is to unscrew the lid of the jar, circled in red. Performing this task without assistance is difficult. Using assistive actions can make this task easier. The user begins by using a snap action to automatically align the gripper with the jar lid. The user then constrains the pitch and yaw of the gripper to maintain this alignment. The user starts a teleop action, which causes the gripper to track the controller in the unconstrained degrees of freedom. The user then approaches the jar with the gripper. After grasping the lid, the user constrains all but the roll degree of freedom to isolate a twisting motion. With this assistance, it is easy to unscrew the lid. Shared control can aid teleoperation, but the menus required to enable different modes of operation quickly become overwhelming. We propose an expert action recommender to predict the most likely next action and its parameters to simplify these menus. We address this problem in an open world setting where the feasible set of actions changes over time. To make predictions, we start by collecting expert demonstrations of actions. We then predict future actions based on what the user has previously done, and display the top K predictions in a menu.
We investigate two methods for performing this prediction. Regression with a nearest neighbor search directly attempts to predict the optimal action and parameters, then recommends the action and parameters closest to this prediction that are feasible. Structured action prediction scores all feasible actions and parameters and recommends the pair with the highest score.
We record an expert demonstrating 3 different tasks: unscrewing a jar lid, erasing a whiteboard, and solving an animal puzzle. Here, we show an example setup of a demonstration for jar opening, and a point cloud captured by the robot during the demonstration. Structured action prediction scores detected planes and teleoperation settings based on how likely they are to be used. The predictions made by the recommender make intuitive sense. A snap action aligns the gripper with the lid. The next teleop action allows for fine-grained grasping. And the final teleop action lets the user quickly unscrew the lid.
Experiments in our paper demonstrate that the expert action recommender can learn likely actions from demonstrations. Structured action prediction outperforms regression with nearest neighbors by a wide margin in terms of accuracy. In the future, we plan to scale the number of actions up and test the effectiveness of the recommendations when novices operate the robot.